They say nothing lasts forever. But what if the footprints of humanity's first lunar visitors are still untouched, 56 years later? In July 1969, Apollo 11 made history by landing on the moon's Sea of Tranquility. But while most people remember the iconic quote, "One small step for man," what they don't realize is that many of those steps are still visible today, preserved not by design, but by the eerie stillness of the moon. No wind, no rain, no life. Just silence. And yet within that silence lies a strange contradiction. While the astronauts left behind symbols of peace and progress, they also abandoned waste bacteria and possibly even biological hazards. Today, more than half a century later, NASA satellites still capture high-resolution images of the Apollo 11 site. The descent stage of the lunar module, nicknamed Eagle, still casts a clear shadow. The exact paths walked by Neil Armstrong and Buzz Aldrin remain traced like ghost trails in gray regolith. But what else did they leave behind? And could some of it pose an unknown risk? When the Lunar Reconnaissance Orbiter passed just 24 kilometers overhead, it revealed something few expected. The site looks almost untouched, frozen in time. But that's only on the surface. Beneath the calm exterior, scientists now believe there may be far more going on. Something that could redefine how we view life beyond Earth. Among the artifacts still present are scientific instruments, cameras, tools, and a flag that's likely been bleached white by cosmic radiation. Yet hidden in the dust are sealed bags containing something far more controversial. Human waste, including feces, urine, and vomit. These were discarded to reduce weight for the return flight. And inside those bags, billions of microbes. The central question now haunting astrobiologists is this: could any of those Earth-born microorganisms have survived in the moon's extreme conditions, with temperature swings exceeding 250 degrees Celsius high? UV exposure and a vacuum environment survival seems impossible. And yet, we know from Earth's own extremophiles that some microbes can persist in nuclear reactors, deep-sea vents, and even inside glaciers. Could something similar be occurring on the moon, quietly evolving under the harshest conditions known to man? The Apollo 11 landing site is more than a historical relic. It may be a dormant biological experiment that has run uninterrupted for over 5 decades. This isn't just about footprints in the dust. It's about what we unknowingly planted into a lifeless world, and whether it stayed lifeless after we left. As plans for manned lunar return missions heat up, and with global players like China and private companies aiming to land near Apollo sites, the debate intensifies. Should we preserve the site untouched as cultural heritage, or open it for scientific exploration, risking contamination of both past and future discoveries? One thing is certain. The moon is no longer just a silent witness. It may now hold secrets that could shake the very definition of life, and we unknowingly may have planted them there ourselves. To understand why Apollo 11's leftovers could be so significant today, we have to go beyond the romanticism of space travel and examine the brutal realities of extraterrestrial exposure. Unlike Earth, the moon offers no protection, no ozone layer, no magnetic field, and no atmosphere. Every object left behind was immediately subjected to intense solar radiation, micrometeorite bombardment, and temperature extremes that swing from 100 degrees night to over 120 degrees during the day. Most materials decay rapidly under such conditions, and yet the Apollo 11 site seems almost eerily preserved. The descent stage of the lunar module Eagle, still standing, was built from titanium stainless steel and gold-covered thermal insulation materials, chosen to withstand the worst. Around it lie scientific devices like a seismometer and a laser retroreflector, the latter still used today, to measure the exact Earth-Moon distance. But among the objects scattered across the landing site, tools, camera, equipment containers, and more, are sealed biological waste bags. And here lies the crux of the modern mystery. These waste bags weren't a casual discard. NASA made a calculated choice to leave behind any mass deemed unnecessary for return in order to optimize the rocket's weight. That included 96 bags of human waste across all Apollo missions, several from Apollo 11 alone. Within those bags are dormant colonies of gut bacteria, skin microbes, and even cells shed from the astronauts themselves. Modern astrobiologists are fascinated by a terrifying yet scientifically valuable possibility that some of these microbes may have entered a form of cryptobiosis, essentially suspending their biological activity to survive hostile environments. On Earth, certain microorganisms can do this for decades. If any such survival occurred on the Moon, the implications would be massive. First, it would suggest that microbial life from Earth can endure and perhaps adapt beyond our atmosphere. Second, it would open up troubling questions about planetary contamination. What if humanity has already unintentionally seeded the Moon with terrestrial life? The concept is not science fiction. It's called forward contamination, and it's a major concern for any future mission, especially those targeting untouched celestial bodies like Europa Enceladus or Mars. The Moon, once seen as a sterile laboratory for exploration, is now seen by some researchers as a contaminated zone. In fact, multiple scientists are now urging international agreements to formally designate the Apollo sites as extraterrestrial cultural heritage zones, places to be studied, not disturbed. But not everyone agrees. Some voices in the scientific community argue that avoiding these sites may prevent us from learning how Earth life reacts to cosmic conditions. They believe that studying the bacterial bags carefully and with proper containment might yield data on mutation rates, DNA degradation, and survival strategies under deep space conditions. Imagine discovering that a microbe has slightly changed or evolved on the Moon. It wouldn't be an alien life form, but it could represent the first Earth life altered outside our planet. The consequences. Profound. But one looming question remains: if Earth microbes can survive on the Moon, what's stopping them from thriving elsewhere? The notion that life, however microscopic, might already be enduring on the Moon challenges not only our scientific assumptions, but our ethical responsibilities in space. At the heart of this debate lies a paradox. The Apollo 11 site is simultaneously a sacred monument of human achievement and a potential biohazard zone. Yet while the media often celebrates the mission's triumphs, fewer discuss its biological and environmental aftermath. In recent years, high-resolution images from NASA's Lunar Reconnaissance Orbiter have reignited interest in what was left behind. Not just machinery, but an accidental time capsule of 1960s humanity, complete with equipment experiments, discarded boots, and personal items. One of the most striking is a small gold olive branch, a symbol of peace. Yet not far from it lie the sealed bags of bodily waste, and next to them a plaque that reads, "We came in peace for all mankind." The irony is not lost on researchers. The detritus left behind tells a dual story of noble aspirations and unavoidable contamination. In fact, some of the relics may already be deteriorating in ways we cannot predict. UV radiation can strip color. Atomic oxygen may wear surfaces, and micrometeorite impacts could eventually pierce even the sturdiest components. Still, despite the moon's harshness, conditions are far more stable than any environment on Earth. No wind, no rain, no life to decompose or oxidize. This near-static state is what makes the Apollo site such a powerful archive. And it's why some scientists argue that reopening or even landing near the site could destroy critical forensic evidence. Evidence that might tell us how both human technology and biology react to a long-term extraterrestrial environment. There's also growing concern about space tourism and private missions. Companies like SpaceX, Blue Origin, and international actors like China have expressed interest in returning humans to the moon. What happens when one of these missions lands a few kilometers away and sends a rover too close to the Apollo 11 site? Could modern equipment accidentally crush the very trails that Armstrong and Aldrin carved into lunar dust? Or worse, contaminate the site with modern Earth bacteria, making it impossible to isolate what microbes, if any, survived from 1969. The answer to these questions might come sooner than we think. NASA's Artemis program aims to return astronauts to the moon before the end of the decade, and it's already causing strategic debates within the scientific community. Some advocate that we must treat the Apollo sites like Antarctica's historic huts, undisturbed zones, protected by international treaty. Others argue that these sites are too valuable to leave untouched. They propose that we launch controlled retrieval missions to bring back some of the materials for analysis on Earth under extreme containment. There's also a practical incentive. If we want to build lunar habitats, we must understand how materials degrade or survive under lunar conditions over decades. The Apollo debris offers a real-world laboratory for exactly that. Still, a deeper philosophical question lingers in our quest to explore the cosmos. Are we capable of leaving a place untouched? The moon is not a blank slate anymore. It's a place where the footprints of the past intersect with the ambitions of the future. And perhaps most chillingly, it's a place where Earth's biology may already be silently mutating. That brings us to an unspoken dilemma. If we discover that human microbes did survive on the moon and have begun to change even slightly, would we be forced to accept that the line between Earth and space life has already been crossed? Would the moon in that case still be considered sterile and lifeless? Or would we have to start treating it as a place already influenced, however unintentionally, by terrestrial biology? The implications for Mars, Europa, and future planetary missions would be enormous. As we move toward a new era of lunar exploration, the Apollo 11 landing site stands as both a beacon of progress and a cautionary tale. What was once thought to be a sterile, unchanging landscape now raises complex questions about preservation, contamination, and responsibility. This isn't just about honoring a historical achievement. It's about deciding how we as a species interact with other worlds. The objects left behind in 1969 were never intended to be part of an experiment in long-term space exposure. And yet, that's exactly what they've become. The descent stage of the lunar module, the scattered tools, the defunct cameras, the faded flag. Even the human waste, all of it has silently endured more than 5 decades of cosmic punishment. And they will likely remain there for centuries, perhaps even millennia, unless disturbed. In an ironic twist, the very lack of atmosphere on the moon, once considered a barrier to life, has made it one of the best natural preservation environments in the solar system. But with Artemis and other missions on the horizon, we are once again on the brink of disrupting that silence. So what comes next? Should the Apollo 11 site be sealed off permanently as a scientific time capsule? Or should we dare to study the biological waste bags under strict lab protocols, risking irreversible exposure for the sake of knowledge? Some argue that the moon should be viewed as an untouched lab, our only opportunity to observe how Earth materials, including microbial life, behave over long durations in deep space. Others warn that such explorations, even with precautions, may forever destroy evidence of what was. We could never recreate the exact conditions of 1969 again. Not the microbes, not the materials, not the environment. Whatever data exists now is irreplaceable. This debate is no longer theoretical. Private companies are gaining the ability to reach the moon. Tourists may not be far behind. And unlike NASA in the 1960s, these new actors aren't bound by the same cultural reverence or scientific caution. One misstep, one rover, one treasure drill, one poorly planned landing, and the fragile traces of humanity's greatest step could be lost forever. It raises an uncomfortable question. Are we prepared to regulate our presence beyond Earth? Or will we repeat our terrestrial patterns, rushing in, and altering everything, and only later wondering what was lost? As science fiction begins to blur with reality, and as space becomes increasingly commercialized, the moon is no longer a distant rock. It's a stage for humanity's evolving identity, a mirror reflecting both our highest ideals and our worst impulses. The Apollo 11 site is not just a monument. It is a silent witness, and perhaps the moon is asking a question back at us. If we cannot protect what we leave behind in space, are we truly ready to live among the stars?